If more than one term has an exponent, distribute the exponents to the appropriate terms and then multiply the resulting terms. So if you had xy to a power of m times vw to a power of z, you first distribute the exponent to its respective term, and then you multiply the resulting terms. So what would this look like? Let's say you had xy to a power of 2 times x squared yz to a power of negative 3. You do want to multiply your like terms x and y, but you first need to distribute these exponents. So 2 times this exponent of 1 gives us x squared. Negative 3 times 2 gives us x to the negative 6th. So after you distribute the initial exponents, now you can multiply these terms. Same thing with the y. 2 times the power of 1 is 2, so we get y squared. Negative 3 times the power of 1 is negative 3. Z to a power of negative 3 is negative 3. So after you distribute the initial exponents, then you can multiply the resulting terms. You may also encounter a situation in which you are dividing two terms that have unique exponents. If the numerator and the denominator have unique exponents, then distribute the exponents before dividing the like terms. So in this case, we have x squared y cubed to a power of 4 divided by x to the 5th y to the 6th squared. So before you can divide your x's, you first need to distribute this 4 to this exponent 2. That would give you x to a power of 2 times 4, which is x to the 8th. Same thing with the y. Y to the 3rd to a power of 4. 3 times 4 would give you 12. Same thing in the denominator. Distribute this 2 to this 5 and this 6. So we get x to the 5 times 2, which is x to the 10th. Y to the 6 times 2 gives you y to the 12th. And now that you've distributed those exponents, now you can divide the like terms in this step. Okay, so let's wrap up this chapter by completing these practice questions. Question number 1, 3x to the negative 5, y squared to a power of 0, divided by 4x to the negative 3, y squared to a power of negative 2. Question number 2, 2x to the negative 3, y to the 4th to a power of negative 2 times 3x squared y to the negative 3 to a power of 4. And question number 3, negative 4x squared y to the negative 3 to a power of 2 times 2x to a negative 4 y to the negative 2 to a power of 3. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, replace the numerator with positive 1. So since we have this entire monomial inside a pair of parentheses, this exponent of 0 is being applied to the entire thing. It's the same as having 3 to a power of 0, which is 1, times x to the negative 5 times 0, which is x to a power of 0, which is 1, times y squared to a power of 0, which is y to a power of 0. So you get 1 times 1 times 1, which is 1. Then you deal with the denominators separately. Two different terms with two different exponents. So this one applies to the numerator, this one applies to the denominator. Step 2, distribute the exponent negative 2 to the coefficient 4. So that gives us 4 to the negative 2. So we'll leave that there until we make this positive. Step 3, distribute the exponent negative 2 to each variable by multiplying the exponents. So x to a power of negative 3 to a power of negative 2 is equal to x to a power of negative 3 times negative 2, which is positive 6. And then y to a power of 2 to a power of negative 2 is y to a power of 2 times negative 2, which is negative 4. So we wind up with 1 over 4 to the negative 2, x to the 6, y to the negative 4. So now we've simplified our expression, but we have negative exponents. So our last steps 4 and 5, we move each term with a negative exponent to the opposite side of the fraction line and make the exponents positive. So that moves 4 to the negative 2 to the numerator to give us 4 squared, and y to the negative 4 up to give us y to the 4th. 4 squared is 16. So the final answer to question number 1 is 16 y to the 4th divided by x to the 6th. Question number 2. Step 1, distribute the exponent negative 2 to the coefficient 2. So that gives us 2 to the negative 2. Since that's negative, we'll leave that there until we make it positive. Step 2, distribute the exponent negative 2 to each variable by multiplying the exponents. That's each variable inside this pair of parentheses, not all of them. So x to the negative 3 to the negative 2 is equal to x to the negative 3 times negative 2, which is x to the 6th. And we have y to the 4th to a power of negative 2, which gives us y to a power of 4 times negative 2, which is y to the negative 8. And now we distribute this exponent 4 to each term inside of the parentheses here. So step 3, distribute the exponent 4 to the coefficient 3, giving you 3 to a power of 4, which is 81. Then step 4, distribute the exponent 4 to each variable, x and y, by multiplying the exponents. X squared to a power of 4 is x to a power of 2 times 4, which gives us 8. And y to a power of negative 3 to a power of 4 is equal to y to a power of negative 3 times 4, which is y to the negative 12. And now step 5, move each term with a negative exponent to the opposite side of the fraction line. We want to get this exponent positive so we can evaluate this term, so we can combine the coefficients, just like we'll be combining our like terms. So let's move the negative exponents to the opposite side of the fraction line. So 2 to the negative 2 becomes 2 to the positive 2 when we move it from the numerator to the denominator. Y to a power of negative 8 is negative in the numerator, but becomes positive in the denominator, positive 8 instead of negative 8. And this y is the other term with the negative exponent, negative 12. So we move that to the denominator as well. 2 squared becomes 4. And now the last step, step 7, multiply the like terms by adding the exponents. So x to the 6th times x to the 8th is equal to x to the 6 plus 8, which will give us x to the 14th in the numerator. And in the denominator, y to the 8th times y to the 12th is equal to y to the 8th plus 12, which is y to the 20th. And that gives us a final answer of 81x to the 14th over 4y to the 20th. And now question number 3. Step 1, distribute the exponent 2 to the coefficient 4. This negative sign is on the outside of the parentheses, so we'll keep it on the outside as we distribute this exponent to each of these terms. So we get 4 squared, which gives us 16. Step 2, distribute the exponent 2 to each variable by multiplying the exponents. X to a power of 2 to a power of 2 is equal to x to a power of 2 times 2, which is x to the 4th. Y to a power of negative 3 to a power of 2 is equal to y to a power of negative 3 times 2, which gives you y to the negative 6. And now we deal with this monomial with this exponent 3. So step 3, distribute the exponent 3 to the coefficient 2. 2 cubed gives us 8. Step 4, distribute the exponent 3 to each variable by multiplying the exponents. X to a power of negative 4 to a power of 3 is equal to x to a power of negative 4 times 3, which is x to the negative 12. And then y to a power of negative 2 to a power of 3 is equal to y to a power of negative 2 times 3, which is y to the negative 6. So now we can multiply these two terms. So step 5, multiply the coefficients. Negative 16 times 8 gives us negative 128. And now step 6, we multiply the like terms by adding the exponents. So we'll multiply our x's and then we'll multiply our y's. X to the 4th times x to the negative 12th is x to the 4th minus 12, which is x to the negative 8. Y to the negative 6 times y to the negative 6 is y to the negative 6 minus 6, which is y to the negative 12. And now step 7, move each term with a negative exponent to the opposite side of the fraction line. And step 8, make the exponents positive. So our x term and y term both have negative exponents, negative 8 and negative 12 respectively. So we move these two variables to the denominator and make their exponents positive, giving us a final answer of negative 128 over x to the 8th times y to the 12th.